Hello grade 10s. Today we're going to be going through the exam memo and I'm going to give you a little bit of examiner feedback as well as some insight as to why I set the questions I did. The winter assessment for this year was based on the Back to the Future films, and hopefully you all enjoyed it and you got the associations. If you have not seen the movie, as I said before, please go and see it or see all three. I think as science students you will really enjoy it. On the question paper, it says 2 hours, but it turned out it was a 2.5 hour paper, and it was for 125 marks. So I think that was more than fair. Hopefully you all read your questions carefully. These are key, guys. I know you guys skim through them, but please read them very carefully because people tend to disregard them and then they lose marks. So what I'm going to do is I'm probably going to go through and have about 3 videos, and each video is going to cover about 2 questions. So this video 1 is going to cover question 1 and question 2. So let's look at the multiple choice questions. It made it very clear what you had to do, although a lot of people put one option. So for example, for every question they put it on a separate page, which I found a little bit silly, but I'm not going to ask questions right now. Let's look at the question 1. Question 1, it's got to do with Marty McFly runs at a speed of 8 meters per second for 10 seconds and then a speed of 6 meters per second for 12 seconds. Which calculation gives the average speed? Now, majority of the options that you were given or were completely bogus. It had to do with either division of the meters and the meters per second and the time, or addition of 2 completely random variables. What I wanted you to do is choose B. I wanted B as the option. B is the option, the correct one, because you can see you are taking into account the 2 separate incidences of speed, and you are putting them together to calculate your average speed, which the average just means overall. Let's look at question 1.2. 1.2 was really easy, and here it was a case of identifying which statements were correct in when referring to covalent molecular structures. Diamond and graphite, as well as silicon oxide, were mentioned here. In this instance, all 3 are correct. All 3 statements are correct here. Majority of you got this right. Question 1.3 exercises your knowledge on moles and concentration. All you had to do was plug and play here based on the formula that we have given you on your data sheet. So I wanted to know how many moles of hydrochloric acid are present in 25 centimeter cubed of solution. So moles is N equals M over MR. So all you had to do was put in the information that you needed, and you should have come out with A. It should be 0.0125. So this was a plug and play question. Okay. And you were given the concentration, so you could have worked backwards using the concentration formula. Which of the following chemical formula is correct for the transition metal compound silver 1 hydroxide? So here we've used the stock notation, and as you all know, the stock notation denotes the charge of the cation, the positive charge of the cation, and hydroxide ion is negatively charged by -1. So all the other options are completely irrelevant. Wherever you see a subscript of 2, that is wrong. It needs to be B because they cancel each other out. They completely cancel each other out. Question 1.5. Again, more stoichiometry. Doc is experimenting with 150 decimeters cube of nitrogen at STP. What is the mass of the nitrogen in this? So you work backwards to figure out what the mass is based on the volume. And guys, you should have chosen D. I do believe that the first question, the multiple choice questions, were pretty straightforward. There was nothing tricky. This was flexing your muscles for the next part of the exam. And as it was only for 10 marks, it should have taken you between 5 and 10 minutes to do this. Really, it should have been very, very quick for you to do this. Let's look at question 2. Question 2 has got to do with atomic structure and electron configuration. And I know you did this a long time ago, okay? But if you studied your notes and you did the past exam papers, this particular question I felt was a breeze, to be honest. Very, very easy. First question 2.1 is asking you to define the atomic number. Now, like I've said before, these are bread and butter marks, and you need to give me all or nothing for this, okay? So I wanted to know it's the number of protons in the nucleus of an atom of that element, and if you didn't give me the full definition, you didn't get the mark. Then it asked you how many neutrons does plutonium have. Guys, grade 8s and 9s are doing this, all right? You literally just minus your atomic number from your atomic mass, and that should give you 150 neutrons. Again, an easy mark, throwaway mark. The name of the group that plutonium belongs to. Okay, so I wanted inner transition metals as per your periodic table. However, if you wrote transition metals, this was accepted. In future, please be specific. That's all I'm asking for. Question 2.4, right, is got to do with these isotopes of plutonium. Now remember, this only represents a few of the isotopes. There's other isotopes of plutonium. There's not just these. So when you get to your atomic mass, your relative atomic mass of plutonium, remember, if it's not as per the chemical symbol that we've given you, that is okay. Right? I look to see, are you calculating correctly? Are you following the method that we taught you? So 2.4.1, I wanted you to explain. You did not have to give me a definition, but you had to explain what it is. So the key phrases here I wanted was the same element, but different number of neutrons in the nuclei. Then 2.4.2, you had to calculate the relative atomic mass, taking all the isotopes into account, for 4 marks. If we look at the memo, go on to our memo over here, we will see that it's pretty straightforward. You take the percentile, you divide it by 100, and you times it by the atomic mass, and that gives you a value, and from that you add all those values together. All right, so I gave you a mark for the relative atomic mass. I gave you a mark for dividing. I gave you a mark for multiplying the atomic isotope mass, and then for the units, okay? 2.4.3, once again, this is a definition, bread and butter mark for orbitals. It's got to be space or region of electron movement, where electron movement is mostly found. And 2.4.4 is Heisenberg uncertainty principle. So this over here, I just wanted you to recognize that it is impossible to determine both position and velocity of an electron without disturbing it. So as you can see, this particular question is heavily theory-based. There really is not a lot of application here. I'm not asking for you to apply something to something you have never even heard of before. The associations are very, very close to what you've done in class. 2.4.5 might have been a bit tricky for you. However, this orbital block was actually shown in a diagram in your notes. So it's asking you, based on the last 2 orbital electron configuration, in which block would you find plutonium, and it has to be the F block. Look to see where is the valency, guys. Where's the valency at? It is in the F block. And this is in your book as well. So this might be a little bit, because we don't really deal with F block at high school, this might just be a little bit extension, but it's still highly theory based on what's in your notes. These 2 questions, 2.5, because the rest of the question was so straight out of the book, I put these 2 questions into like, let's throw a span in the works. Let's see what they really know. Can they build up an argument? So 2.5 asks about the relationship of electronegativity and ionization energy. And over here, for 3 marks, you needed to say that Doc was correct. You needed to show that electronegativity is the attraction of an electron to an atom, and ionization is the energy required to release an electron from an atom. And what I wanted you to show is that there is a direct relationship between the two concepts, because with one comes the other. If I have a high electronegativity, I'm going to have a high ionization. The memo refers to the breakdown on this, but I looked at that structure over there. I wanted to see, can you associate the two? Can you link the two? Then for question 2.6, I wanted to ask about atomic radii. Okay, now I know that you've never worked with these metals before, maybe in naming, but not really working with them. I wanted you to look where they were, and I wanted you to motivate as to whether you think they're similar. Now, as per the book, they actually are very similar, but even if you didn't refer to the book and you had another argument, I would still mark you right if it made sense. I hope that. So if you said yes, both transition metals, I would have given you 2 marks. If you had said no, there's an energy level difference, which means the radius would be different, I gave you the mark. So this question 2.6 was open-ended and it was argument based. Okay. That is it for this video. This is video 1. The next video is going to cover question 3 and 4.